Okay, I had a student ask for help with um, explaining the empirical rule and Chebychevs theorem. So, for the empirical rule, there's several things that you have to know in order to use the empirical rule. You have to know what your z-score is, what your standard deviation is, and what your mean is. So first of all, we know the mean is 365,000, and we know the standard deviation is 41,000. So we have to figure out what the z-score associated with a range of 99.7% of the homes falling with around the mean. So the empirical rule, and I just pulled up one on Google. There's all kinds of graphics. There's some in your book and in your PowerPoint. But basically, what the empirical rule says is 68% of data values fall within one standard deviation of the mean. So a majority of your numbers will be one z-score or less away from the mean, so fairly close. And this is assuming that it's a bell-shaped curve. There's no outliers. And then it says that if it is a bell-shaped curve, in other words, the numbers are normally distributed, then 95% of your values will fall within 2 standard deviations of the mean, and almost all of your numbers will fall within 3 standard deviations of the mean. So we want to know the upper and lower limits for 99.7%, and so that would be 3 standard deviations. So basically, you're going to take your standard deviation and you're going to multiply it by 3 if it's 99.7%. You're going to take your standard deviation and multiply it by 2 if it's 95%. And you're going to take your standard deviation and multiply it by 1 if it's 68%. So once you multiply your standard deviation to get your upper limit, you're going to add it to the mean, and this is your mean, so you're going to add it. So you can see that you're going to take, for R's, you're going to take 3 times the standard deviation, and you're going to add it to the mean, and that's going to be your upper limit. And then you're going to take your standard deviation times 3, and you're going to subtract it from your mean to get your lower limit. So this number on your lower limit and the number on your upper limit is going to tell you that 99.7% of your data values will be between those 2 numbers. So let's go back to the actual problem. And so first of all, I know now that I'm going to take the standard deviation and multiply it times 3. So if you do your standard deviation of 41,000 and you multiply it times 3, you're going to get 123,000. So to get my upper limit, I'm going to take this 123,000 and add it to the mean. And if you look at the problem at the top, you will see the mean is 365,000. So if you add 365,000 to 123,000, you will get your upper limit of 488,000. And then to get your lower limit, you're going to do the 123,000, which was 3 standard deviations. And the standard deviation is 41,000, which is 3 times 41, we said was 123,000. To get your lower limit, you take the mean and you subtract the standard deviation, which was 123,000. So your lower limit is 242,000. What does that mean? Given that the data is normally distributed, 99.7% of your values will fall between 242,000 and 488,000, meaning that 99.7% of the homes in the county will be between these two numbers. Now, Chebychevs is a little bit more difficult to compute, and you can look in the question help to see the formula, but basically what you're going to do is you're going to take 1 minus the percent and 1 minus 0.83, so that would be a 0.17. So once you get that number, that is what you're going to divide by. So you're going to always do 1 divided by the 0.17, and then you're going to take the square root. Okay? So if this was 90%, you would do 1 minus 0.90, which would be 0.10, and 1 divided by 0.10 and take the square root. So 1 divided by 1 minus 0.83, 1 divided by 0.17, and then take the square root. And then this is your z-score. So 0.83 or 83% is 2.425. We're going to round to the third decimal place here. So if you do 2.425 times your standard deviation, which is 41,000, this is your magical number to add and subtract from the mean. So your upper limit would be 365 plus 99,425. So you would get 464,425, and then 365 minus 95,425, and that would give you, actually, I think I put the wrong number in. Let me look at my notes here. 365,000 minus 99,425, and you would get 265,575, and there would be your limits.